All right, folks, just getting started here. So we're live and we're streaming Trelis live stream. We're on YouTube and also on X. I think comments are only possible on YouTube. So there will be a stream on X, but it's only going to be broadcast and not available for comments. Whereas on YouTube, I think if you're logged in, you should be able to join the chat here and throw any questions as we go along. I am hoping to add it to LinkedIn as well. Once the page gets 150 followers, that's Trelis Research on LinkedIn, I'll be able to stream it across there as well. So in advance of what will hopefully be weekly streams, you should be able to post comments on either Twitter, YouTube, or you can post them on LinkedIn. I have a few comments in here in advance, two kind of questions to go through around. The first is preparing a consolidated report. If you've got many reports, how do you get a language model to integrate those into a final report of a certain structure? And I have another question here on pre-training for a new coding language. So if you have a language model that, say, can code in a few different languages already, but not the one you want, how should you go about doing that pre-training? So I might give a few comments on these two questions here a little bit later on. A few other things I want to get through on this stream. We have about an hour. I'll go through a multimodal model called MoonDream. It's a really small model, but it runs really fast, and I've been surprised how good the quality is. If you've watched the Trelis Research channel, you'll see there's already a video that came out on the Llama multimodal model. It came out probably about a month ago now, maybe 2 months. And since then, there's been the release of the Idefix or Edifix model number 2, which was soon going to support text generation inference. That's going to be a nice feature to have because Lava is quite difficult to deploy. Even if you fine tune it, it's just not easy to deploy it as a model. So I'm hoping to do a video on Edifix. But actually, while I was researching Edifix, I came across this model called MoonDream. I think it was somebody in maybe it was a comment on Trelis.com, and they just said, "Here, when are you going to do a video or on MoonDream?" I didn't know what MoonDream was, so I went and took a look. So let's actually dig in on MoonDream now. I want to show a quick demo of how we can get an API live. And if somebody wants to suggest a picture or an image, I need a URL. We can query it and ask some questions about that image and see how good the model is. It's really small. It's only about 3 gigabytes in size. But I've been impressed with how well it does. It's been trained on OCR, so optical character recognition. So it's actually able to recognize fonts within an image, which is pretty impressive for a model that's so small. So let's give that a crack. We'll look at the MoonDream model. We'll look then at Mixtral 8x22B. There's an Instruct model that has just been released, I think 22 hours ago, maybe 24 hours ago now on Hugging Face. And that model is, it's going to be nice to use because it's chat formatted as opposed to the base model. So we'll set up a one-click template for that. I'll talk a bit about figuring out how many GPUs you need to run inference on it. I haven't set up the template yet, so it's a good opportunity to do that. And then I think I'll move on to these other questions and maybe handle a few others if they appear in the chat. All right, so let's take a look at the MoonDream model. So I'll head over to Hugging Face and MoonDream. Hopefully everybody can see me here on the screen. I'm just going to adjust things a little bit so that you can see the screen a little bit bigger. So here we are with the MoonDream model. And you can see the weights. It's about 3.72 gigabytes, so fairly small model. The model is a combination of a vision model and a text model, which is the same with Lava. But the text model this is based on is Phi 1.5. And the vision model, I don't think it's listed here. It's not the clip vision model. We can maybe go here to the Hugging Face repo, check out a few more details. So yeah, it's based on Phi 1.5 and the weights from SIGLIP, which is a specific type of vision model that's trained with a sigmoid function. I haven't read in too much more on that. And then we have Phi 1.5. And it's kind of interesting that Phi 1.5 is the base, because there's a Phi 2 model that's out, which is stronger. It's also bigger though. So potentially in keeping the model small, that was maybe a motivation for going with Phi 1.5. But yeah, even still, as you'll see, the performance is pretty good. So what I'm going to do is set up an API so that we can send a request to the API to ask it a question about an image that we send in. And the way I'm going to do this is by using the one-click LLMs repo. So this is a public repository that anybody can go on. I'll actually just throw it into the chat here. And by the way, I also should put in a link to our live stream collab. So I'll just copy over that link so that you can follow any of the topics that we're covering here. That's the collab notebook. So I'm here in the one-click LLMs repo, and there's a wide variety of ways you can deploy a language model or multimodal now with one click. And we're going to do it on this MoonDream model, a small but accurate model for querying images. So that opens right up to the run pod template page, and the template should be loaded. So if I scroll down, can I even see the template listed? I know that it is because I've done this before. So let's just keep going. Yeah, here's the template, MoonDream Multi-modal API. And okay, we're saying please zoom. All right, I'm going to have to get good at the chat. Hopefully this is a little bit better here. Question, why do you suppose OCR performs at all? Is the question there, why is it good at OCR? I assume because they've trained it on OCR data. In fact, one of the sample notebooks they have on the repo is to fine tune it on character recognition for CAPTCHAs, and it works really well. So I assume that's why it's working. Okay, so we're here and we're kicking off this API template, and you can go with any GPU. You could go with a smaller one here with 16 gigabytes of VRAM, because this model, when it's loaded, is only taking a few gigabytes of VRAM. So anyway, you know, my favorite is the A6000. So I'm going to go with that, and I'm going to deploy it here on demand. Now, when I go to the pod itself, they've just changed the UI a little bit on run pod, and the README now, I think it'd be better if they said README, but they have it as a question mark. So there's all of the setup is described here. And there are a few things I want to say about how I've set up this API. It's an API that supports multiple concurrent requests. So you can have users, or you can be sending in a request now, and then 5 in a second, and then 5 in another 10 seconds. So that's called batching. And the way that it works is with a batch size and a timeout. So the batch timeout is the number of seconds that it waits to accumulate a batch. So if I send a request, the server's going to wait for, it defaults to 1 second. So the server's going to wait 1 second to see if any other requests come in. And if other requests come in, it's going to parse them together and send them in for a batch inference. Also, there's a batch size, which is the maximum amount that will be inferenced at once. You could probably set this a lot higher than 5. I think I've set it to a default of 5. But because GPUs, they're very effective at doing parallel operations, it's a great idea to probably increase that up. Maybe even like 32 would be fine. So this form of batching, it's kind of a simple approach. It's not as good as what's called continuous batching. Continuous batching is where you have one request that's going in. So I set in a prompt like this, and when the first half of that prompt is processed, the next request comes in. And basically, you need to merge like part of the first request with the second request so that you're able to do this continuous batching. But that involves more complexity, because it means that you have to dynamically set up the tensors so that you have these partially competed responses that are being put in with the new requests that are coming in. That's something that TGI does. That's something that VLLM does. That's why they're pretty good. They're pretty good options, and I'd love if they supported multimodal. But the thing is that multimodal requires image input, so it's a pretty big extra variable that needs to be supported. And I'm not sure how big a priority it is for those two libraries to support images. Maybe it'll happen, but in the meantime, we have this kind of simple batching server I've set up. All right, some other parameters here. So we're going to be using the model ID of the MoonDream 2, and we're going to be using the revision. Revision is another word for branch on Hugging Face. The branch is going to be the April 2nd branch. And there's this other parameter you'll always see within my one-click templates. It's actually supported now by VLLM. This means that you're using HF transfer. It allows for a Rust library to be used when you're downloading the weights, and it can download at sometimes up to 1 gigabyte per second. So this really accelerates downloading models, which is really important or valuable if you're doing large models like 8x22B, which we'll cover in just a little bit. Okay, so once that pod is up and running, which has been running quite a while for now, you can just hit this endpoint here. It's a chat completions endpoint. So I've kind of made it a bit like OpenAI, and you need to input your pod ID here. So here's an example of a full request. And this full request here is for an image that is at this URL. So I've just gone to Wikipedia and I've grabbed the URL for a picture of the moon. And then I have, you can see this very familiar format here. I have an array of messages. I've got the user messages and I've got the assistant messages. And you'll see there are a lot of backslashes here. That's just because if I use this as a terminal command, then I'm going to need to escape these double rather apostrophes. That's why there's the slashes, which you're probably not used to seeing. Question from Kevin here: with batching, would you get more throughput if you sort the request prompts alphabetically, such that common prefix phrases and prompts could be better utilized in the KV cache? If you sort the request prompts alphabetically, such that the common prefixes could be better utilized in the KV cache. What you're implying is that there would be some reuse or sharing amongst the prompts. And as far as I'm aware, that's just not done, because if you try and share information or compute between individual prompts, it really ties everything together. And the kind of loss of flexibility you have in that is just yeah, that outweighs any benefit you might get in terms of speed up. So I'm not aware of any algorithms where you would specifically allow them to be tied in a way to get a speed up. Okay, so let's just copy paste this here. And there's one adjustment I need to make, which is I need to put in the actual pod I'm using. So if I go back over to the Trelis live stream, I've just got this box where I pasted in a curl command earlier. And what I need to change is this pod ID. So let's go across and grab the actual pod ID, which is going to be this one. So I have my pod ID here, and I'm going to crack that in there. And now I can copy my whole curl command. So I have the whole curl command is copied here. And what I'm going to do now is I'm just going to go to a terminal. So let me just pull that up and then drag it across onto the screen. Okay, so I need to minimize and create a bit of space and move this and put that there. All right, great. So here we are. Let's just create a clean terminal with the old Control-T and paste in the curl command. Sorry, this is very white. I know people sometimes really dislike such a white screen. I'll figure out how to do it reverse for the next time. So yeah, here's the command, and I'm going to press enter. You can see the question is just what's in this image. So I'm just asking what's in this image of the moon. And let's hope for the sake of integrity of the stream that this works. Yeah, so the image features a close-up view of a full moon, which is the main focus of the scene. The moon is round and appears to be dark black and white color scheme. It's positioned in the center of the frame. All right, so yeah, this is pretty good stuff. This is pretty good stuff. I'll actually just pull up what the picture looks like so that you can have a look. Wikipedia full moon. Here we go. Yeah, there it is in all its splendor. Yeah, so that's the moon that's been described, and yeah, it's just it's quite incredible how such a small model is able to describe things fairly accurately. And the beauty about the model being so small is that the inference is just really fast. So I'm going to do a full video on this model. I've actually done some fine tuning already. I've done it on chess pieces with like 42 photographs, and it's able to fine tune. Like my experience fine tuning it has been better than fine tuning the Llama 1.6 version model. It's not getting all of them correct, but 42 photographs is not a huge amount of data for it to still improve quite a lot on that domain. My suspicion is that the OCR training, so the training to recognize text, really improved things a lot. The other thing I'll show in the video is I'll show the batching in more detail. So I'll send in batches of like 5 followed by 5 like every second, just so you can see kind of the latency. But generally, I found that when I use this specific GPU, the A6000, I'm able to send in I'm definitely able to send in probably 5 requests a second and get response times of no more than 5 seconds for each of those. So I think this is a really cool model to hack with and to build probably edge device products as well, just because it can run nicely locally in principle. Now, I haven't dug in on whether it works really well with Llama CPP or Llama CCP. You can have Llama CPP. I think there is some work in the repo on Llama CPP. But when I just tested it out naively, it didn't seem to default to using metal, which is needed for getting good speed up. And the last thing I'll say on this is, yeah, I think what this shows is it shows that you can probably do like even better, because Phi 1.5 isn't the best model. You could certainly plug in something like even a Quen model. I was thinking there's a Quen 1.8 that's quite a bit stronger. You could probably even plug in the Phi 2.7. It would be bigger, but it would still be small. So I see a lot of potential on this in terms of where it's going. And yeah, just I suppose another last comment. I keep saying last, but the way this model is built is in 2 pieces. You just take an off-the-shelf vision model, and then you take an off-the-shelf language model. And the only thing you do to connect them is you put in a single multi-layer perceptron. So you basically just have one layer of matrices that are adapting the outputs of the vision transformer to go as the inputs into the language model. And just to give further detail on that, if you think about an image, your question is, well, how do we put the image as an input to a language model like Llama 2? Because Llama 2 takes in tokens, and we get those tokens from words, and the tokens go into embeddings. Well, the answer is when you have a vision model, this is broken into a patch, into a set of patches. So you can think of maybe a 3x3 grid of patches, and each one of those patches is converted into an embedding. So there's a vector representation for each of the patches. So there's not a representation for every pixel. So you might have a very large number of pixels, but that's not the level of detail at which you have the embeddings. You have the embeddings on a patch by patch basis. So for example, if you have a context length, and I think the context is quite short for MoonDream, maybe 512, you're only going to use up a few. You're only going to use up a few of the embeddings for the image. I don't know exactly, but it's on the order of maybe 50 to 100. You're not going to use up, say, 1,000. All right, so I see a question. I'm going to move to that question, and then what I'm going to do is talk a little bit about Mixtral 8x22B. Specifically, I want to talk about the Instruct version. In there, and all. And what have we got here? We've got a random question from Jonathan. When training a model like OpenChat, I can show this on the screen. Isn't that's beautiful? When training a model like OpenChat for function calling, would this form of training work for agentic flows, e.g. agents being prompted with available agents so they know who to call based off a prompt? Yeah, so with function calling, what I've done videos on so far is where you typically will have just one function called, or maybe the model needs to call a function, get information, and then call another function. I think, well, not I think, but in the case of agents, agents are agents because they do very many function calls. So they take very many independent steps. Otherwise, it's not really an agent. It's just a function call. So you have these trajectories, and obviously your trajectories expand somewhat exponentially as you move out that binary tree of what's possible with each subsequent call. So the question is, can you fine tune them in the same way? And I think, yeah, the answer is yeah. But where it potentially can work well is where there are some pretty common trajectories. So if you have a customer agent that is inquiring about or supporting concert tickets, let's say, and they're trying to manage questions where somebody needs a refund, there might be a refund trajectory that has maybe 3 different steps. And so you can definitely give conversation data in and fine tune on that trajectory and then some other trajectories. And that probably can stabilize your agent framework fairly well. All right, so let's move back and talk about Mixtral 8x22B. So we'll head over here. And I'm going to do this from scratch so you can all see how I build one-click templates. And hopefully that'll be illustrative. And just a few clarification questions on the language models. Yeah, let me just quickly answer those. So Kevin is saying, when you combine the pre-trained language and vision models together, does any training need to be done for these layers? Yeah. So you've got these untrained, like this untrained perceiver layer or like connector layer, and that's just initialized in some way. There's no obvious way to initialize it that I can think of. So that usually would need to be trained. So there's this kind of a question of, well, do you need to do pre-training? So do you need to do unsupervised fine-tuning with the whole model? That might be one option. Option two is you could freeze the vision and freeze the language model and just train that connector layer, perhaps with unsupervised fine-tuning. I think that actually might be what Llama does in the first step. So they're kind of your two options for the first step. Probably the fastest thing is just to train that connector layer, because fundamentally the vision model and the main model are probably fairly decent. So yeah, you freeze those two, train the middle layer, and once that's done, you can maybe move to LoRa fine-tuning and do some supervised fine-tuning, or perhaps even better, ORPO, do some preference plus supervised combined, and that can allow you then to update all of the weights. But because you're using LoRa, that maybe gives you a bit better smoothing. So that'd be my gut feel. All right. That's a nice feature there. Just putting that there. Lovely. All right. So Mixtral 8x22B. This is the biggest open source model Mixtral has released. It came out in the base form maybe a week or two ago. Previously, the largest was 8x7B. So this is about 3 times larger. It's a mixture of experts, which means that there are 8 models, and I think only 2 of them are going to be called. Now, that's a slightly inaccurate way to think about it, because it's not like there are 8 independent models. This happens at every single layer. So if you have a 50-layer model, there's actually a mixture within every single layer. So you're in layer 1, then 2 of those experts will be called. Now you move to layer 2, 2 will be called. And there's no association between which are called in layer 1 and layer 2. So anyway, that's a technicality. But because this model is bigger, it's more powerful, and it's especially more useful now that they have provided an instruction fine-tuned model. Now let's see if there's any information on how it was instruction fine-tuned. And another beautiful thing is that it supports function calling, which I need to look into more detail. But that is something that we're seeing now with companies that go beyond OpenAI. OpenAI was kind of the only one doing that for quite a while, but now it seems like everybody's jumping on the function calling bandwagon, which we love to see. So here, what was my question? My question was, are they going to tell us how they instruction fine-tuned it? And the provisional answer is not on Hugging Face. Well, we can probably assume they did some kind of supervised fine-tuning and preference fine-tuning. I'm not sure if ORPO made it in time for them to use that. I don't know if they like ORPO. I personally like ORPO because it seems to work a lot more reliably than DPO. And you can check out a video on ORPO if you like. There's one on the Trelis channel, as there is for Mixture of Experts. So anyway, let's have a quick look at the weights before we make a one-click template. All right, yeah, that's a lot of weights. 59 safe tensors, and each of them are just under 5 gigabytes. So if it was 5 times 60, that would be 300 gigabytes. So you've got 300 gigabytes of weights. So if you have an A6000, that's 48 gigabytes. So you need to have at least 6 of those. And I think in practice, you probably need 8. And for an A100 or H100, that's 80. So you would need at least 4 of those to be able to run this model. And that doesn't leave all that much space for the context length. Now, one small little note there is that the context length affects the number of GPUs you need, because you need to have space for the KV cache. You need to have space for that long context interacting with itself, because each token has to relate to every other token. And that usually means you need more space in the GPU. But because it's a mixture of experts, it's not as bad as you might think from a model that's about 170 billion parameters, because you're only activating 2 of them. So your KV cache is not growing nearly as badly as, say, a Llama 70B model. Okay, so here we have the weights, and what we're going to do is define a one-click template for this. So I'm going to head over to RunPod. I can probably close this down here, save a few euro, and I'm going to go to my templates. And am I going to cheat? I'm going to cheat a little bit here. So I built another model that's kind of similar to this recently. Not built a model, I built a one-click template that's called Zephyr. Now, I want to do Control F. I'm not sure why. Oh, there we go. ZEPHYR. So that's Zephyr 141B. So this is actually also a chat fine-tune. And this chat fine-tune is done, was it done using Orpo? Not entirely sure. But I assume that the Mixtral one is better, because Mixtral and Mistral as a company seem to be beasts on cleaning data. That is my best guess of why they're so good at delivering high quality models. So yeah, I would assume their data is pretty good on the instruction fine tuning. And so I would assume their model is stronger on this. And it's probably not just assumed, because you can actually look at the metrics, which we could do, but I'm not going to get distracted. So let's duplicate this template and change it to Mixtral 8x22B Instruct and TGI API. All right, so a few things here. We're going to make a text generation inference template. I don't see why this wouldn't work with VLLM, because if the previous mixture of experts worked with VLLM, it would also work. I like TGI because it has this thing called speculative decoding. No, well, it does have speculative, but it has oh, what's it called? With flash attention, you have flash encoding. Yeah, TGI is flash decoding. So as your context gets longer and longer, this tends to slow down the speed of your inference. And basically similar tricks that can be used in flash attention can be used in the decoding part. And that's actually been built in to TGI. I don't know, maybe VLLM is working on it. Also, TGI, it was on an Apache 2 license, and then it was on this kind of strange license where it was basically Apache 2, but if you want to use it to deploy an API for your company and serve other people, you need to get permission from Hugging Face. Anyway, it's back to an Apache 2 license. So it's in the same category as VLLM right now. All right, so we've got the container image. I've got the word latest here so that if there are updates, we will get the latest image. Probably a double-edged sword. It can be better to pin a specific image here so that if something happens that breaks things, it's not going to break because you're fixed. So we're going to change the model to Mistral AI, to this one here. And we are, what else are we going to do here? So yeah, often trust remote code is put in. I don't think that's needed because the files are in safe tensor form, and I don't believe there's any code that's being run. If it was needed, you would see it being listed here. So you can kind of leave it in. From a security perspective, you should be careful putting it in if you're using a model, especially if it's like some random model from Hugging Face, because it means it can run code. Now, I'm on a GPU from RunPod, so at least you know that is an isolated instance. Okay, so max input length, max total tokens, max batch prefill tokens, and then speculate. Yeah, so TGI supports speculation. Speculation means that it kind of guesses what some of the future tokens are and pre-calculates those so that if it gets the next token right, it can automatically accept future tokens. And speculative decoding done this way is done using n-grams. So what it does is it takes like patches from the input. So if you start off, let's say you have a long paragraph and you say, give me a summary of this paragraph, it's going to make use of like n-grams, blocks of words within your prompt to guess what the output might be, which works really well if you're trying to summarize, because often a summary has got some similar sequences to the input prompt. So you get some speed up there, maybe 10 to 30%. this is a pretty naive speculation approach. It gives you a small speed up, but it's fairly low on computation compared to some other approaches like Medusa, which give you more speed up but are more complicated and not easy to set up. Okay, so my disk volume is 300. How much did we say it was? 60 times 5. I know it'll probably fit on that, and container disk of 10 should be fine. 8080, this just means we're going to expose the 8080 port, and that actually has to match what's in the Docker file. So I'm not just picking this arbitrarily. I'm matching this to here. And in the environment variables, I've got the Hugging Face enable HF transfer, which gets us the fast weights download. And yeah, this is a big model. So let's see how this goes. Okay, so we're going to go up. I'm going to copy the link off of that. Mixtral 8x22. Oh, they call it. All right. So I'm going to copy this link and I'm going to paste it in, and we're going to try and get this running. Is it possible to fine tune a large model using GAN architecture? That's adversarial networks. I mean, yeah, probably. It's an interesting thought. I would need to look into it in more detail. But I like the idea of using structured data, like say using a piece of Python code to make polygons and then training a language model like to recognize those polygons. Like I like these kind of mathematical structured way, because you can do things repeatably without having to have human or synthetic prompt generation. I guess it's kind of synthetic, but it's way better. And then when it comes to adversarial networks, why do I like those? Yeah, I suppose I think they're like a big part of what DeepMind have done. Say the stuff around chess and Go. So yeah, they're just a few thoughts. So I'm going to run this template, and what am I going to do? I'm going to run it on my favorite. I'm going to run 8. And I'm going to deploy. And I'm going to go to my pods. And I'm going to check what the README says. Now, I haven't prepared the README, so yeah, the README is not exactly correct. I need to go back and fix that. Just a few things. Yeah, you can actually fit this probably on smaller GPUs. So you can use this flag, just put it into the command window, and you can use 4-bit quantization. This is a normalized 4-bit. What does that mean? It means instead of kind of spreading out the quantization levels with equal increments, it makes them normally distributed. And this is actually a better pattern because weights are somewhat normally distributed. So the quality is quite good. Like this is a quite good 4-bit quantization. The problem is it's quite slow. It's usually 2 to 4x slower. So you will fit this. You'd be able to fit this on a quarter. You'd probably fit it on 2 A6000s using this, but it's going to be slow. There's no kernel. There's no specific, there's no kernel. There's no specific way to calculate, to dequantize those weights and do the inference very quickly. It's like a multi-step approach, and that slows it down a lot. So there's one other quantization type. I should probably just write this because we're waiting anyway to load. So let me, and here you can see the downloading, and it's it's downloading fairly fast thanks to HF transfer. So let's go back to the templates and find the Mixtral. Do they call it? They call it Mixtral 8. No, they call it Mixtral 8x22. And let's just adjust the README. So Mixtral. Okay, so we've got one flag for bits and bytes. And let's make this an option here. Or you can add quantize EETQ. EETQ is an 8-bit. And in an 8-bit, you should be able to run on 4 A6000s or 2 A100s in 8-bit. And Generally, what I hear and what I kind of find is that 8-bit works really nicely for quality. 16-bit weights for inference, generally when you make them 8-bit, you don't really lose any quality. So this is nice. But the nicer thing about ETQ is there actually are kernels. So they've managed to make it kind of a single step as possible during the inference. And yeah, you don't need to add a Hugging Face Hub token because these are, oh, do I? That's an interesting question. It doesn't look like I did need to because it was downloading. But I remember this morning I had to accept something on that repo. So I'm slightly surprised I wasn't asked. Oh, you know why that is? That's because my container hasn't even started. That's because my container hasn't started. So I'm not even at that point yet. I suspect I may actually need to put in this token. And there's probably no better time to do that than the present. So let's go down here. Yeah, because I did accept. I did accept something a bit earlier. So I'm going to go to settings. And I'm going to copy that and put it in over here. And that might be just in time. Let's see. Yeah, sharding on 8 processes, token file not found, download file. Okay, now we're sucking diesel. All right. Yeah, so I'm making these updates to the template just so you can add that quantization flag. And I think we're in good shape to save that now. And once this does get up and running, this is how we're going to send a request. I'm going to copy that over here just so I can put in the run pod ID. So once it's all downloaded, looks like we've got quite a way to go. You can see the 8 GPUs going here. And in the container logs, you can see, yeah, I'm only on 3 out of 59. I don't know if we'll make it, folks. I don't know if we're going to make it. But I'll put the pod up on the one-click templates so you can try it out yourself. It probably is the strongest model currently available open source, I believe. Yeah, there's a question on 1-bit quantization using a very big rank LoRa with high quality data set related to quality, accuracy, and elucidations. How is the adoption and what are the implications? Yeah, so if you do 1-bit quantization, what happens? Well, one of the, aside from the obvious issue of precision, which I think papers like the 1.58-bit paper, which has since been replicated, I think, by Noose Research. But if you look on arXiv, there's this 1.58-bit paper, the era of 1-bit LLMs, and they find that they can train a model from scratch using 1.58 bits. They don't find a lot of accuracy in taking a fully trained model and then quantizing to 1-bit. That seems to be very difficult. And since then, I think there may be some people that have had better success in quantizing to 1 or 1.58 bits. Now, a few comments on whether that's useful. So even if you got the accuracy working, the main benefit and then the main drawback, the main benefit is you need less VRAM. So you're going to be able to fit the model on smaller VRAM devices, like maybe your laptop. So that's good. The problem is most computers are not designed for doing computation in 1-bit or 1.58 bit or 2-bit. They're designed for doing computation in 16 bits sometimes, but a lot of the time 32 bits, maybe 64 bits. So even if you have this model that's in like a single bit or 2 bits, you have to dequantize. That's actually the same problem I talked about with bits and bytes earlier. You have to dequantize. And so you don't actually save any computation. You end up doing the same number of calculations. And so even if you can fit this model on your laptop, like you still have the same number of flops that need to happen. And so, yeah, that can kind of be pretty slow. So can you use very big rank LoRa? Well, yeah, certainly if you can get a model that's already quantized and has reasonable perplexity, like reasonable accuracy, then yeah, you can probably fine tune it using a LoRa, I think. Interestingly, something I didn't appreciate for a while was that LoRa adapters are generally in 16 bits. So when you're fine tuning a quantized model with QLoRa, actually your adapters are in 16 bits, and that helps a lot with stability. Now NVIDIA, they support 8 bits on their top current series, like the H100s. They actually allow 8-bit calculations within the GPU. So that actually does save computation. Like you can kind of fit 2 calculations instead of 1. And I believe Blackwell is going to support int4, so they'll support like 4-bit. But I don't know of architectures that are supporting 2-bit. But yeah, it would be nice. Would be really nice. There's kind of this philosophical question of whether it makes sense to build language models like kind of binary or with some kind of non-binary, like higher numbers. I wish I could frame that question properly, but maybe if I could frame it properly, then I'd be closer to an answer on which makes more sense. Yeah, okay. We do have, how are we doing on time? I've got to finish off this template. We're doing pretty good. I am going to answer the question on adding a new programming language to a model's capabilities. Marlin quantization. Yeah. What's the story with Marlin quantization? Let's take a look at what Kaichup says. Right. Yeah, you can see I left a comment on this. This is great. The Kaichup, highly recommend. Highly recommend. Marlin. Let's see. Maybe my comment down there will remind me of what I thought about Marlin. I should also respect Kaichup because it's a paid publication for a lot of these. So let me just see if I see my comment. And AWQ weights, Marlin, somewhat unusual to add tokens in the batch, plot them. Yeah, okay. I didn't really have any good comment there. Let's go back to read. Okay, so large. Let's try increase this. Large models are too large. Yeah, okay. Mixed autoregressive kernel. Yeah, so this is addressing the problem with bits and bytes, which is that there's no special kernel that actually handles the dequantizing and multiplication. So it is providing a specific kernel. And yeah, I think why aren't people using it? So generally, my sense is that a lot of people working with production models are running in 16-bit. They're running in BF16 or FP16. And that's partly because the highest speeds are achieved with those in TGI and VLLM. And I don't think you're going to get faster inference by going to quantized. So it's just this extra step if you actually have to quantize the model versus just focusing on doing 16-bit fine-tuning, which is going to give you the best quality, and then it's going to, like, straightforwardly, without having to mess further with the model, allow you to run inference. So I think it's not really like a lot of people are using bits and bytes, I'd say, for production systems. It's a bit slow. I'm not sure if many are using EETQ. And yeah, like when it comes to throughput of your machine, if you're running large batch sizes, at some point you end up being compute bound and not being memory bound. And if you're being compute bound, then you don't really get any benefit from quantization. Like quantization really is giving you the benefit of fitting the model onto smaller GPUs, which is good for doing like running in collab, or if you want to run on edge devices. And then like you're probably going down the GGML or GGUF route. Also, yeah, there's inertia. So Marlin, I think my conclusion now I remember, my conclusion was that Marlin probably is a better choice, certainly than bits and bytes. Although I'm always a big fan of the 8-bit because I think that's given really good quality and maybe decent speed. So, all right. So here we are. I'll add this in later, the Mixtral template that I've just built up. And it's going to take quite a while. You can see the volume is slowly being filled up here. If you take a look, let's just take a look at Twitter, because I did a post on Zephyr, I think, over the weekend. So maybe I can find that and the kind of rates that I'm getting out of it. ZEPHYR. Yeah, so I did it on Zephyr. I know the fonts are probably small here, so. All right. So yeah, this is the Zephyr fine tune. It's probably not quite as good as the Instruct model that I'm just making now. Oh, wow. Llama 3 came out. Okay. Well, maybe we should take a look at that. Yeah, let's take a look at that in a second. So yeah, Zephyr 141. Yeah, anyway, all I wanted to say here is that when it comes to the inference speeds, did I write it here? I think I was, getting 20 talks, generating 500 tokens. So this is the kind of speed, and I'm almost certainly going to get the same speed when I'm running Mixtral 8x22B. All right, so we have this question here I'm going to go to, and then we're going to talk about this non-question here. So assuming you want to fine tune a model, can I move my head? Nah, it's fine. A coding model with a programming language that wasn't pre-trained on, yeah, how would the training data look like? So there's actually a case that I'm thinking about a video for right now, which is somewhat similar to this. And the case is adding a language, say, for example, Irish. So Irish is not very well supported. There's an Irish Wikipedia, but it's not very big. And so the quality of discussion from Irish that you get from certainly like Llama 7B, or who knows how good Llama 3 will be, but the quality is not great. So the question is, how do you fine tune it on Irish? And the parallel question here on coding is, how do you fine tune on a specific type of coding? Now, yeah, I suppose my gut feel for the coding is you first of all start off with a coding model, and you probably want to start off with a DeepSeek model, maybe. My experience has been the DeepSeek coder models have been stronger than the Code Llama models. I also like starting with like a kind of, let's call it a big company model, as opposed to like some derivative that's been off fine-tuned. I think some of the fine tunes of the main models can be quite strong, but it's unpredictable exactly what data has been done. And so, yeah, that means the model may be aligned differently than what you expect. So anyway, I like starting with like a base model from a company, which now will be Llama 3. But yeah, start with DeepSeek maybe. And from there, if you want to teach it that specific code, I suppose you could do some unsupervised fine tuning, and that's what I'm planning to do with Irish on a base model, before then doing some ORPO. So yeah, you could do some unsupervised, but I think because it's code, because code often has got a clear finish and a clear start because it's delineated by files, potentially there's a way to generate some instruction tuning sets fairly straightforwardly. For example, even if the language model, like say a teacher language model or just a separate one you're using for data set prep, even if it doesn't understand fully the code that you're trying to train it on, it's probably going to be able to classify it roughly into what the code is doing, just because there's going to be English words within it. So my sense is that you can probably generate some questions to go along with answer pairs. So generating a question answer pair might not be too bad. You should also be able to develop a preference fine tuning set just by taking that same question and getting like Mixtral to generate a response, which is obviously going to be bad because it's not trained on this new code language you're talking about. So in that way, you have your files of code, you synthetically generate questions to make a question answer data sets. And then additionally, if you want, you could make it a preference set by taking that prompt and running it through a language model. My gut feel is that, yeah, I don't know, actually. I probably shouldn't have a strong gut feel on it. I think I was going to say that maybe training on a new code is easier than training on a new language. But maybe that's not true. I think one of the issues with the new language is that Irish is going to have a different token. Like I don't think it makes sense to use a new tokenizer because that's an effort in itself. But Irish is going to have, vocab. Yeah, do you need to train a new tokenizer? I would try and shy away from that just because, especially during prototyping, you want to do the minimum possible and see what you can get away with. So you want to take the best possible open source model and start there and not mess with the tokenizer. And the tokenizers are big. Like maybe it helps if you like use a model that has a larger tokenizer, like Llama. Llama has a huge tokenizer. Maybe that's a benefit if you're moving to another domain. But what I was going to say is that in Irish, like we have accents on the vowels. We also don't have certain letters, like we don't have J, we don't have K, we don't have Y. So that tokenizer distribution is going to be quite different. Now in coding, the syntax is different. So that also will make the average token distribution different than what you would see in a different code language, or indeed in a normal language. So is it harder to fine tune on coding than on Irish? I'm not entirely sure, but maybe I can think about that. Okay, nice. We have a blockchain question here. I'm setting up let me throw it on the screen. I'm setting up validators on a blockchain, and then the last few minutes we're going to go Llama 3. I'm setting up validators on a blockchain that uses LLMs as proof of work, and I need a robust method of validating the LLM response. Validating the LLM response that uses LLMs as proof of work. Okay. I don't think I'm following the question fully, but my answer when I hear validation is usually outlines. So if you go to outlines, this is supported by text generation inference. In fact, there's a video. Let's see if I can, what did I call it? Structured response. I know it's probably really hard to see the top of my screen there. Yeah, structured responses. Anyway, there's a video that's covering structured responses. Is it here? Function calling. No, it's probably in the advanced inference. So if you go to advanced inference, have I got some videos? Yeah, data extraction. Yeah, actually in the all sort, this is where you want to go. I know this is about a technique for doing kind of a form of RAG, but this talks about using outlines, and that allows you to say, I want to have answers of a specific format. Now, I'm not sure if that's what you're getting at with validators on the blockchain, but if there's some kind of programmatic response, then that's going to be really nice because it's going to limit hallucination a lot. So I would give that a look. Basically, they serve inference, and I have to check that there is a real LLM. Okay, maybe that's not what you're asking. They serve inference, and I have to check that there's a. So this is. Are you checking that there's not a human? Yeah. Okay. All right. So let's see what's happening with Llama 3. I don't know if I can. Can I just do this, or should I go onto Twitter? Yeah, wow, it just appeared. Okay. So this looks. Okay. So the future of Llama 3, I suppose, like the question here is, can I get it on Hugging Face? And I was also wondering if they like might release a vision model as well. How like they let me load Llama 3. Oh, you have to agree to it. Is it here? I was wondering as well if they'll upload to the same repo or if they'll go to. Oh wow, that's class. Yeah, that's tasty. All right. Llama 3. Here we are. I'm also that's nice. Like they've released the 7dB version, and I was expecting maybe just a small one. Llama Guard. That's 8B Instruct. Okay. So what did they not release? They didn't release a 14B because that's what they released last time. I mean, that's okay. And I need to agree. Wow. I need to agree to a lot of stuff. Okay. I need to agree to a lot of stuff. Let me agree to a lot of stuff on another page here. Yeah. How do you know if an LLM is just responding versus human? If it responds 42, then it's real. Yeah, well, there was a study done on randomness of LLMs, and I believe that it pretty much is very non-random in quite large part because of Douglas Adams and 42 from Hitchhiker's Guide. So there's a great video by Veritasium on YouTube about the number 37, which if you ask people about random numbers between 1 and 100, they don't randomly pick a number. They might pick like really low numbers or really high, like 1 or 100, but then otherwise they tend to pick 37. I mean, they pick 42 a lot, but if you throw that out, they pick 37. So people kind of gravitate towards prime numbers, which is interesting. So sorry, I'm just doing some paperwork here and submitting so I can get approved. Now, it would be interesting whether we need to wait or whether that's fine. Wow, they're really putting a lot in there. Okay. Llama Guard. Llama Guard is an 8 billion. It can be used for classifying content. Okay. All right. I kind of like this idea. I mean, I know a lot of language models are way too censored, or at least that's a common view. But I like the idea of controlling how to censor something, because clearly if you're running a chatbot for some business, you need to be able to put some guardrails on it. I was kind of thinking of maybe doing a video on that at some point. Okay, 400B is training. Interesting. Wow. Yeah, I don't know. Like, I kind of feel these models over 100. I'm a bit skeptical. I think it seems to me like they're just undertrained if you're going to make them that big. I suppose, like, maybe from a chinchilla standpoint, it's kind of optimal to do economically because for a given amount of compute, it's optimal. But like the Grok model, I've been underwhelmed with that, and it's just huge. And it's so huge that people can't really do anything with it, and so you don't really get a lot of people trying things. Yeah. Okay, if you want to beef your machine to run the 70B for a future video. Yeah, cool. I appreciate that. All right, so let's take a quick look here. We're going to wrap up anyway in a minute or two. Acceptable use policy. Okay, it's pending a review. That's interesting. All right. Well, I guess we'll have to come back, except let's see. There's probably somebody anyway who's pushed a model that's like a fine tune of it. It's interesting they're calling it Meta Llama opposed to just Llama. There's news research coming in quick. Or is it new research? That would be, yeah, I guess it is new research. Now that I say it, that makes a lot of sense. How is the Command Or V1? Yeah, Command Or, I think Command Or Plus, the latest one, is quite strong. They have insanely good documentation, and it's open weights, but it's actually not free to use commercially, which I don't see why. I feel like Llama 1, they had a research license on it, and then they got rid of it. So I kind of think Cohere and Command Plus probably will end up doing the same thing. 35B model. What's a third? Yeah, there's no 35B. That's true. I think did Meta release? They definitely released like the code Llama 34B. Did they release a non-code Llama? Maybe they did. Anyway, here's the 8B, and so 15 trillion tokens. I think Llama 2 is like maybe up to 5, so that's pretty good. context length 8K. Okay, that's a bit smaller than I expected. I know font size is small. Wow, that's a weird layout. So 8K, that's a bit shorter than expected. But yeah, that's a lot of tokens. I wonder like how many tokens the Mistral models are fine-tuned on, because I wonder if they've done a lot of training or if they just have really good clean data. My suspicion is the former. I also like Mistral, they're building smaller models, and I think it's a good constraint. Like if you're forced to build a small model, it gets you to think differently about what you're doing, and I think you probably end up getting like really good models from that. Which is the best open source model for needle in the haystack? Yeah, definitely coding models. Coding models perform very well on that, and DeepSeek Code Llama is pretty good on needle in haystack. All right, so let's just take a quick look at the weights. It's interesting as well that it's 8B. Like, why? What's different about the architecture? Is the kind of thing where Daniel Hahn at Unslot will maybe tweet about it at some point. So yeah, it's a bit bigger. Like it's actually over 15 gigabytes in terms of weights. And I wonder if Hugging Face Chat has got it supported yet. I'm not entirely sure if this is going to work on. Let's see if we can very quickly make a template here. I'm going to stay on for another 10 minutes just to make the Llama 3 template. So let's copy this one. And let's do code Llama 7B. Oh, it's not code Llama. It's Llama 3 8B. API. And I'll paste this in here. Can you talk about how to select the amount of data? Here's a question unrelated to what I'm doing here. So yeah, we need to have like probably I'll just put 20 gigabytes here, and yeah, I think this should be fine. There's no guarantees this is going to work though, because see, there's probably somebody who's created an issue about Llama 3. Okay, there's no Llama 3 issues yet, but there will be momentarily. And let's try and run that. Yeah, so can you talk about the amount of data and structure required for fine-tuning related to selected base model? And I think, was that you asked as well about Karpati? No, that was somebody else. The effectiveness of fine-tuning depends on distribution of the pre-training data used to train the base model. Well, yeah, that makes sense. I mean, if you're doing fine-tuning, there's two ways to think about it. One way is that you're literally adding more information, and the other way is that you're shifting the probability distribution to move like in a certain direction. So if you think about having a mountain that's green and a mountain that's red, like if there's a lot of information about the reds and greens, using something like preference fine-tuning, you can shift the model towards the red, and it's gonna kind of shift it over here, which is still relying on a lot of the underlying data. So that's the shift, but there's also the add. So adding is where you're adding new knowledge to it. And I don't know if this is what Karpati is saying, but if you have a lot of underlying data, then you're able to kind of shift or prioritize different parts of that surface that you're operating on. So you're able to move towards different parts of that surface. But if fundamentally there is no surface, or it's a really bumpy surface because it's a bad base model, then you're kind of restricted to only adding new data to it. Yeah, this is being recorded, I hope. I'll throw it up onto YouTube and maybe onto Twitter as well. Oh, yeah, okay. So this model here is loaded, and it's just waiting for the shards to load. And the other model I want to run, and we're going to run Llama on an A6000. So what are we going to do? We're going to change that template. Llama 3. Llama 3, yeah. I must have done something silly. See if we search for 3. See if we just go down to the bottom. No. You know, I probably didn't rename it. Oh, here we go. Yeah. All right. So we'd only need 1 GPU for this, and we'll deploy it. You know, I kind of feel like just running the 70B one, to be honest. Go for it. Make it way larger than it needs to be. That's not going to work though, because I need to 70B. This is, yeah, so that's not going to fit. It's not going to fit on this GPU, so that's a bad idea. 70B, even if I use EETQ, I could use bits and bytes, but it's so painfully slow. I don't think I should do that. 8B. I can't go backwards. That's fine. So let's create another template for the 70B model. This here. I assume that News Research has a 70B model, which could be a bad assumption. Yeah, it's a bad assumption. It's a bad assumption. So, Llama 8B. Yeah, I'm actually using News Research because the Llama one is gated and I don't have access to it yet. So our friends over at News are doing us a favor. Technium, you can follow him on Twitter. Good content. Yeah, so I mean I can actually search. Probably somebody else has got one up. And the other thing I need to check is whether I made a mistake on using the instruct. Yeah, I did make a mistake. I'm making a lot of mistakes here. So 8B instruct. Yeah, okay, well, it's not that bad a mistake, but I definitely want the instruct version for the obvious reason that we want to have a chat. And I'm a bit surprised somebody hasn't pushed to 70B. All right, somebody has made an MLX. Wow, that's nice. MLX is like Llama CPP, which is for fast inference on a Mac. GGUF. Can I do something with that? I mean, I think I can. So I can do something with that. It's a bit of a hack, but let's see, they have the files first. No, there's no files. This is also getting into territory where using a random model is probably not the wisest. Doesn't look like there's any weights here. If there was GGUF, I could probably find a template here for Llama CPP, and I could adjust that to run the GGUF. So that would have been the hack. Yeah, and I do not have a Mac that's capable of running this, and I don't know a way to run that on Ubuntu, although it probably is, but it would be quite under-optimized. All right, so it looks like we are getting close to being loaded. Has anything crashed? No. This is where we find out if TGI supports it out of the box. We can look, by the way, at the model architecture a little bit. Not that one. Oh, I've been granted access. That's great. That's great. It's a bit annoying because people have to put in their Hugging Face access token, but so the thing I'm going to do here is I'm going to test this out on a reverse test So like give it a sequence and ask it to reverse the sequence. That's how I like to test these models. And this one here, I can now put in the 70B model. And this is looking good. Okay. So here we have the Mixtral 8x22B, which is taking a long time to load, but you can see the shards are loading here. And here we should soon be loaded. In fact, we are loaded. So this probably is ready to hit, which is what we want. Yeah. So here, remember, I'm just going to copy this and paste that here, which I've already done. No, I haven't. Okay, so that's good. And the other instance I want to run is the Llama 70B. So here I need to run it on at least probably 3 or 4 of these ones, but I'm going to go big and do 2 A100s and deploy that. There's no instances. All right, that's a pity. Do I want to just pay more? All right, throw money at the problem is a solution there. Except I foolishly selected the wrong pod, which I'm now going to retrospectively fix. Okay, it's downloading the container, which is fine, but it's going to have to. This was not my finest hour. I need to go back and fix the base template as well. So if I have any issues, you need to put in the Hugging Face hub token. So need to go to README and select this. Why don't you use serverless with VLLM? Yeah, that's a good idea. There's serverless. I have a video on that. Serverless is like a little bit tricky to set up. That's not the right thing to do. I want to paste it down here. All right. And then I do need to get my token from here. Yeah. I don't know. I definitely wonder whether it's worth it for Meta to make you put in an access token, because I think it's adding friction and people will end up just copying the models onto other repos. And that means people use the base. Whoops. I save that now. But that is not what I wanted to do. So yeah, I just needed to roll my key there, and I'm going to replace it because I've rolled it. So I'm just putting that in. All right, so we're back here and we're trying to run a few things. We're trying to run the 70B, we're trying to run the Llama 3 8B, and we're trying to run Mixtral Instruct. Let's take a look at if that's, yeah, it's waiting for the shards to load. You can see the shards are loading, so things are happening. The first one that's ready is the 8B model, and it's ready to be hit. And so I've got my curl command ready here. And let's start off with this basic curl command. See if that does anything for us. Sorry, the font's going to be kind of small. Something I need to do at a system level to improve that. All right. Okay, deep learning. Yep, so we've got some kind of reasonable response. So that's looking good. And now I need to increase my max tokens by a little bit. And I need to ask a question. So, all right. So, all right. So we have that sequence, and we're going to pass it in. and ask the language model. Okay, wow. That's kind of poor. That's kind of poor. Let's try something shorter. So here I'm just asking to do sequences in reverse, which is quite difficult. Language models. Yeah, wow, that's kind of crazy. I wonder why that is. Give me this in reverse. So I'm even giving some kind of HTML tags here just to see if I can help it. Not optimistic. Yeah, okay. Wow. So just by contrast, if I do something like that, if I do something like that and I go to the GPT, it's going to have no problem. And it should have no problem even on the GPT 3.5 model. So let me pull that in here. And here, let's say this. Okay, so yeah, you can see like it's getting that correct. And the whole idea is, by the way, this is GPT 3.5. If you move to GPT 3, that was GPT 4. If you move to 3.5, does that look good? No, that's bad. That's wrong. It's got an extra O. So yeah, this is like this is kind of a hard task that you can use for these models. And you can see that GPT 3.5 is not able to get it, but GPT 3.5 is able to get it. And you can do some other tests. So let's go to Hugging Chat. See what models are on Hugging Chat. So if we use Command or plus, see if it manages to get this correct. Now the problem with using Hugging Chat is that I don't think I can control temperature. Oh, did I make a mistake? Maybe it did get it right. I'm clearly worse than the language model. It did get that right. I was reading it wrongly. IOONDIOPF. No, I got the end wrong. I did FP instead of PF. So ChatGPT did get that wrong. But if I look at the Command Plus model, which is very strong, did I get it wrong? GPT-4? That's really bad. FP0. All right, maybe our test is too hard. This is also getting it wrong because it's getting two eyes at the start. Now, I can't control the temperature on this model as easily. So that doesn't help. There is one trick that I can do. So you can use a chatbot UI. So chatbot UI, it's now got a V2, I think you download on your desktop, but it allows you to plug in an API key and then make use of a chat interface. And the beautiful thing is that you can, well, one is you can export it as conversation. So it's actually really useful for generating fine-tuning data. But also you can control the temperature like this. So I'm just going to see what it says. Other than that, there's some issue with that model name, I think. Yes, let's try this one. Oh, yeah, I know the issue. The issue is I don't have an API key. And that's going to be, I can put in an API key, but they've moved me to prepaid. And I don't think I have a credit card on file right now. So I don't know if I can do that. All right, let's keep moving here. We're almost loaded with that model. How's the 70B model? It looks like it failed. Yeah. And that's probably just based on my stupidity. Yeah, it's just bad syntax. I've just made some kind of typo in the prompt. Yeah, it's literally just this space is missing. What happens when you rush things and don't use a template. Let's just double check I have that correct. I think I do. Yeah, it does look correct. All right. All right. So yeah, I guess I'm not hugely impressed by the model, the 8 billion model. Yeah, this has been recorded. Yeah, simple identity functions. Yeah. Yeah, reversed. Yeah, the reversal test is hard. And yeah, as you mentioned, the GPT-4 model makes a mistake here on FP. And in this case here, does it reverse it? OPF? No, it is missing the O. So that's incorrect, although it does reverse the PF correctly. Okay, I'm going to have to head off definitely within the next few minutes, and I'm worried this may take more time than we have, although the download is working now. But there are 30 files to download. And oh my God, this is slow to load. This is why the 400 billion parameter Llama model is not something I'm hugely excited about. Okay, there's let's just see at the rate at which this is downloading. If it's downloading okay, then I might be able to make it. 7 out of 30. Yeah, I suspect this might just take too long to download. I will let me just answer one of the last questions that I had. I don't know if I've missed any in the chat. If you have any, just throw them in now. I have a question here on consolidated report generation. Imagine if you have 3 department reports and you want to consolidate into one report of a specified format. How would you make use of fine tuning and or RAG and or long context as appropriate? So yeah, this is more outside, I think, of fine tuning, because the first thing I would do is probably use something like Google's Gemini model with a really long context of 1 to 1.5 million tokens and inject a sample of the template report that I want to get out. And then as context, put in the 3 department reports if they fit. So that probably would be my first approach. And I would only move to fine tuning after that if I found that for some reason the tone or style of the reports, particularly the tone or the word choices, are not exactly what I would like. That would be the only reason I'd probably move to fine tune in a report preparation case. So a question here, do you think it's possible to use a 30B in a real production? I already tried the 7Bs and still with a long delay. Yeah, I think if you're doing it in production, you need to have GPUs. So you need to be running it on, 70 times 2 is 140. So within 2 A100s, you're just kind of fitting in with 20 spare, 160 minus 140. So I think if you run a 70B maybe on like 4 GPUs and you run it in 16-bit to try and get the fastest speed, that's kind of the best you're going to do. Try and keep the context length short in order to keep the response time high. But this is ultimately why I think something like Mistral, the 7x8B models make sense. Even the 7x22B with 2 of those activated, it's 44 billion parameters. So it's not quite half, not quite 2/3 of 70, but still going to be a speed up. I think as well, like there's quite a big speed difference between what TGI and VLLM are able to do and what commercially is being done by companies like, say, Lepton or like Mistral themselves. So there's a few kind of tricks that are being used in the inference that don't seem to have migrated yet to open source or being developed. So folks, I'm going to wrap this up. I put way up at the top a link to the spreadsheet here, to the Google Collab, and you can check out any of the content there. For next week, we'll try go at the same time. If you have any questions in advance, throw them up onto YouTube or Twitter. And in the meantime, you should be able to see these templates. I'm going to put them up onto the one-click template, one-click LLMs repo. I'll put up a copy of the 70B one, and I'll put up a copy of the 8B one as well. The 8B one, as you can see, it is responding reasonably well. It's certainly responding, but the quality of the answers wasn't that great on the test that I just did. See how far I am. Yeah, I'm actually getting close. 26 out of 30. Probably won't take too long for that to load. How to select what data to put in RAG versus fine-tuning, and the fine-tuning data should be partially put in RAG. The fine-tuning data put in RAG. I'm not sure. Putting the fine-tuning data in RAG. Yeah, I mean, generally, I'm not saying much interesting, but you're always going to try and use RAG first before trying to do the fine-tuning. And only then would you see if you need to fine-tune the model, unless you're very constrained on context and you just need for speed. If you have a need for speed and can't afford to put long context into your prompts, then that will argue for doing fine-tuning over doing RAG. But other than that, you're going to probably want to try just to inject context using RAG first, using some combination of simple search like keyword search combined with RAG. Ideally tagging as well your raw documents, so the documents have got like headers on them, so that these kind of taggings will also help. Potentially, if you can kind of design a graph type search through your data before doing RAG, all of these techniques are probably worth doing before going too much towards fine tuning. I suppose if you want structured responses, that's where fine tuning can be helpful. It can help guarantee that you're going to get certain formats, certain lengths, and in combination or instead of that, you could just use techniques like outlines I talked a bit about earlier, but by constraining the regex to specific format of the output, you can fairly significantly improve the performance. Looks like we are going to have time here because I see that GPUs are loading. We have about, 140 gigabytes of weights that need to be loaded, and they're going to be loaded onto 2x80, so 160 worth of VRAM. So we should be seeing this at above 80% probably of loading. So let's just, yeah, there we go. So we are actually loaded. It took a bit longer than I expected. And now what I'm going to do is just replace the run pod. Going to replace the run pod ID here and copy that curl request. So we're going to test that same request. What's that? So you can see here it's taking a bit longer. Ooh, here's the answer. I suspect there's like an issue with the chat templating. I don't know why, but yeah, it's actually, yeah, I'm not sure why it's responding like this, because I'm using the instruct-based model. So there's something that's a little bit interesting about the instruct model. I wonder if it's just the TGI defaults are not exactly matching, and maybe the way that this is being prompted. Yeah, I mean, it's recommending apply chat template. So really, yeah, it is supported by text generation inference here. So that's why it's working. And it looks like they're changing the tokenizer format potentially. Let's see if we can find the tokenizer config. So here you can check out the chat template, and yeah, like they've moved away from, it looks like they've moved away from the inst at the start and the e-inst at the end. So that's a pretty significant departure. And then the chat template here, it's, yeah, it looks more like the chat ML type format. It looks kind of different. So I wonder if there's some kind of issue. But regardless, it has responded in a way that's sensible. And it's not getting it right. It's not getting it right. You can't see that, sorry. Sorry. I'm blocking everything. Yeah, here we are. So yeah, the reverse of this sequence here, it's IOONDI. It's replacing an O with an I. So yeah, and let's see, when I send in that curl command, I just don't remember if I set in the temperature of 0. So I think here what I can do, is this. I can do that. So I think I can just pass in temperature, and let's see if it makes any difference. Okay, well, that worked. So it definitely allowed me to lower temperature. And yeah, did that work? No. OPF. It's got an I, it's got an O instead of an I. So there you have it. I mean, it's just a very difficult test. I guess, as we pointed out, GPT-4 failed. So it's not as though GPT-4 is too strong on that. We can try just do a new one. I mean, I think, let's see what GPT-5 does here. FPOIID. Yeah, it gets that right. I mean, I've seen GPT-5 get responses up as far as 20 correct. And I would very much expect that if I'm running the Llama 70B, the V3, it's going to get it correct as well. DIIOFP. That's actually wrong. That's so funny. GPT-4 is getting the reversal of this sequence incorrect, which is pretty bad. And let's just try it. One last test before we wrap things up. Throw this in here. Give me the sequence in reverse. And I'll copy that curl command over to my terminal. Let's see what it comes back with. You can tell because it's slow that it's over generating text, because it really just should respond quickly. Yeah, that's yeah, I think it's not exactly giving me that back correctly at all. So yeah, I'm not entirely convinced that my formatting is correct here. I suspect there may be some more setup that's needed to make sure that the correct the first two characters are wrong again. Yeah, was that true on both of them? FP, yeah, that is wrong. Yeah, it's actually making the same mistake as GPT-4. So it's not a very useful test. If everything fails it, then you can't really tell which model is better. So maybe that wasn't the wisest way to test it. But either way, I'm going to put up the TGI templates. I will need to look at them in a little bit more detail because the chat templating doesn't seem to be exactly right. Another thing I would probably try is I would, instead of hitting that endpoint, which is I'm just hitting a generate endpoint, you can actually hit a chat completions endpoint, an open AI style endpoint. So that's something else that I probably would consider doing. In fact, that is probably what's happening. That is probably what's happening in this case. I am just putting in raw text, and because it needs a chat template to be applied, it's not generating something that should be sensible. So if I did hit the OpenAI format, that would actually work. I can just show you very quickly, maybe if I open up advanced inference. I know I keep saying I'm going to finish this, but let me just see if I can get the chat templating working. I need to just move screens temporarily while I load this. So just bear with me. So I'm going to open up advanced inference so that I can run some scripts that have everything set up. Yeah, So this is a repo that I use as a base for quite a few of my videos on Inference, and I'm in a speed tests folder here. So I'm just going to run some speed tests using TGI speed, and I don't actually want to use the TGI endpoint. This is a bit confusing, but I'm going to use the VLLM endpoint because it's OpenAI style. But I'm going to hit a run pod endpoint. So let's just check here. I'm going to need to put in the model name and this here. That API key I've deleted. So here I'm going to run with runpod VLLM. So sorry, I'm going to run with runpod here, runpod TGI, and I need to specify my pod ID. So the pod ID is back here, and I've got that. A model with more than 50K context size. Yeah, I think the Yi model, there's one with 200K context size, so you could look at that. So here I've got runpod, and I'm on the 8080 endpoint, and I need to put in the model name. So have I got any model here? Model equals, and the model I want to put it as is the Llama model, which I can just get from here. So I have that. And save. So now I'm going to hit that endpoint, which is the same. But I'm going to use the VLLM script. And basically what VLLM does, it always applies the chat template within, like, internally. So you can't see me calling the chat template. Whereas with TGI, you need to apply the chat template by yourself. So actually here, this will work with my code because I do apply the chat template to the request. So if I run a speed test here, I can actually run either of these. I can run the TGI one, or I can run VLLM, which will hit an OpenAI style endpoint. And the message that we want to write, something like this. And I just want to reduce the number of tokens that I'm going to produce just to keep it shorter. I think my default is 500, so I'm going to reduce that down just to 50. Save. Now I'll run Python. Need to activate, first of all, my environment. So let's say IN bin activate. And now I'll run Python TGI speed py, saying it's a gated access. So this is again the same issue that I had. And I think this is hacky, but I can put in the news research. In the news research model here, because that is not gated. And the chat template should be the same for the 8B and also the 70B. So here, if I go for Llama 3, there we go. I need the instruct one, and I'll just copy that. So here, I'm going to put in this. See here, I'm just manually reading the tokenizer so I can apply the chat template before sending the request to TGI. So I do need to have access to whatever tokenizer that is. So that's why it wasn't allowing me to make use of the tokenizer. All right. So I've just gotten an answer back, and you can see that I've accidentally submitted too many messages. I'm asking it to write an essay on Spring, but I only want to ask it once. So anyway, this is working. And you can see the chat templating is working. So the reason it wasn't working before is because I was sending in a raw curl request without any chat templating. And if you do that, the model expects the prompt to be pre-formatted, so it's not going to respond in a reasonable way. So now everything is working, which allows me to go back and put in the same request about reversing the sequence. So now we can ask, give me this sequence backwards. I don't really expect it's going to improve performance, but try it out like this. So now send in that request. Should be quick to respond. Oh, interesting. Okay, this is kind of cool. So give me this backwards. The word backwards is DIIOFP, and it gets the FP wrong. And then it says, I think I made a mistake. The word FPOIID spelled backwards is actually DOIOFP. Wait. Oh, okay. Yeah, that's kind of disconcerting. And something trivially easy and see if keeps on trying to correct itself. The word dog spelled backwards is God. Yeah, so that's what that is. So yeah, I mean, it's getting the simple one correct. And if I run Python VLLM speed, this is where it's using the native chat template. So it's pulling the chat template from the model within the VLLM endpoint, and then hitting VLLM. So yeah, it repeated the mistake again. It's somewhat funny that it's doing that. So let's see if do I get a response off of this API endpoint? Yeah, okay. So using the VLLM point, it's giving me a long essay on the topic of Spring. And you can see with VLLM, I'm submitting the messages in this message array format, which is the format that Llama 3 is recommending as well. So let's just try put in that original question. I suspect you may be right that the FP is what's catching it out. Although I think honestly, there's probably a few things that's put out. Notice as well, when I'm getting back the response from OpenAI style endpoint, you can see it's giving this full detail. So 500 words of response, but also all of this other information around response choices and the length of the response and such. Okay, so, and just for reference, we're getting about 26 tokens a second. But yeah, wow, it's not managing to solve this problem at all. And it's spelled backwards. It's still getting the FP wrong. And it's also responding in this weird way with the assistant. So I'm not entirely sure why that formatting. I may need to look back at the code at what I'm getting back, but yeah, it shouldn't really be. I may need to add that as a stop token is one option I can think of. That would certainly stop it from generating more, but I'm not sure why it wouldn't already have the stop token built in. It may not have the right stop token specified in the tokenizer, or at least being passed through to TGI for that to work as expected. So anyway, you can see that it is responding in some meaningful way, but it's not managing to get the exact response right. All right, folks, finally, we are finished. Yeah, I've put the link right up at the top of the chat to this. And any questions for next week, throw them onto X or onto YouTube. Appreciate everybody listening, and chat to you soon. There'll be a video out hopefully very soon on MoonDream. It's already in the advanced vision repo, and I'll be hopefully making one on Edifix, another vision model, soon, and then getting on to some unsupervised fine-tuning, hopefully training on an unknown or lowly known language. All right, folks, that's it. All the best.